Hola a todos, bienvenidos a mi canal Desarrollo y Arquitectura Digital. Mi nombre es Henry Delgado y en esta ocasión tengo un invitado especial con nosotros, Tony Sneed. Él es un colega y un gran contribuidor al desarrollo de software. Y en esta ocasión hablaremos del diseño guiado por el dominio y al final Tony mostrará un demo que muestra de forma práctica su experiencia en el uso de estos conocimientos. Así que Tony, bienvenido.
Hello, Henry. First of all, thank you for inviting me on the show. I am thrilled to be here and very excited about what we have to talk about today and the message that's going out to your audience. My name is Tony Sneed. As Henry mentioned, I currently work as Chief Technology Architect at Hilti Group, which is a company that creates tools and components for commercial construction. It's headquartered in Liechtenstein. Henry and I, of course, work for the same company, and we've been working together for a number of years now. I actually come from a developer background. I've spent time working, for example, for the Walt Disney Company early on. I also was a developer trainer for some years, a consultant, finally moved into solution architecture, and now I'm helping to head up the architecture strategy for our business unit at Hilti. So with that, I'm really glad to be here.
Awesome. Thank you, Tony. That's a lot of background and experience that we have in the house. So I'm excited that you are giving us some of your time and your experience with this topic. So speaking about domain-driven design, so we've been speaking about this subject in many episodes in our channel, and we have a lot of interest from people from Spain, Peru, Colombia, Mexico, Argentina, Chile, Ecuador, Venezuela, Panama, United States, that the list goes on and on. So thank you for helping our Latino community. This is a really important topic, and people seem to be very interested. So why do you think this is such an important topic nowadays in software development?
Yeah, absolutely. Thank you for inviting me on, and happy to talk about DDD. It's been around for quite a number of years now. Eric Evans wrote the book on domain-driven design, and he wrote that book in order to lay out a different approach that had been taken up to that point in designing software systems around business capabilities. And so that's really what DDD is all about. It's a way to build applications that allow us to evolve that application as the business rules and requirements become more complex. Right, so that the software can keep up with that complexity, and it has several kinds of concepts, such as bounded context and a lot of terminology that you'll hear. We'll go through today, and but really the purpose is about really bringing business people and developers together into the same place and getting alignment between the two groups. The terminology that we use should be the same among the two groups, the business stakeholders and the developers. And really, it's really about getting everybody on the same page. And then when you do that, you end up with an architecture that really reflects the business. And the things that you do, the services that you create are scoped according to the capabilities of the business that you want to support.
Awesome. So every time that we have new people coming and joining the channel, they have a lot of questions about DDD. Is it going to work? Is it something trendy? Can you share any pushbacks that you are usually encountering when you speak about domain-driven designs in your teams?
I think one of the things that I encounter is just the different the learning curve essentially that's required, right? So that it is not something that I think is practiced perhaps even by the majority of developers and architects in our communities, but it's something that is growing in popularity and something that's really used to solve a business problem. I think the thing that is important to keep in mind is that it's just one tool that you have, and it's not necessarily appropriate for everything. Where you really want to apply DDD are on those cases, those use cases where the business requirements are going to be complex, right? Where you have a set of complex business rules. It's not really intended for what we call CRUD operations, where you're just reading data from a database and writing it back and maybe showing a grid. You don't need full DDD for that. But what you want to do is apply it in the situations where the business rules are sufficiently complex and they're likely to change over time. And this kind of approach to software development helps you to do that. So I think that's pretty much, the pushback that I've received is maybe it's some developers think it's overkill, and it might be overkill for your situation. So you really want to use it in those cases where you feel that it's needed to support the kind of complexity that you're going to see from the business end.
I see. So some of our audience members, they start speaking and asking questions regarding the databases. So they have that mentality of databases. And so they always wonder, how do I apply that to the database? Where do I start relating this to a table? And so what would you tell people like that? How is this paradigm a little different when you start working in a domain-driven approach?
I think there's a couple of points in there. One is that it's where you start, right? Traditionally, a lot of us in development have started with the database, and we create the database schema, and then based on the database schema, we build our application and our various layers. This approach challenges us to flip that around a bit and to really start from the perspective of the business entities. And what are the objects in your business that you need to represent your business? For example, customer or orders or inventory or what have you. Start with those entities, and then the database then just becomes kind of an implementation detail. And what we do in DDD is we abstract that away with a repository pattern. And the reason we do that is, first of all, to make our system more testable, because we can easily mock out repositories. And secondly, that layer of abstraction that sits between the rest of our code and the database allows us to change things if we want to. We can change to a different kind of database. We can go from a relational database to a document database, or we can even decide to use caching if we want instead. And that then making those kinds of changes then has minimal impact on the rest of our code if we take this approach.
That is great. And I'm aware that you have your own library for working with domain-driven design and also a few other utilities. I'm going to let you talk about it a little more later. But before, why don't we get started with some specifics on what makes domain-driven design unique? What are some of the aspects and topics that we speak about when we work with domain-driven design?
Yeah, so you'll hear a lot of terminology. One of the first things you hear is something called ubiquitous language. And it's a kind of a fancy term, but basically all it means is that the words that you use to describe artifacts in your code are the same words that the business uses, right? So, and that meaning of that word is contained within what we call a bounded context. So already we're throwing some words at you, but essentially all the bounded context means is simply a given business capability, a given business domain that you're working in. And so the reason it's called a bounded context is because you use a word like customer, and it's going to mean something different in the order context as it would in say, for example, customer management system, right, where you care about different things. So if a person's placing an order, you might care about their credit history, or their order limit or their spending limit, things like that. And you don't necessarily care about those things in other contexts. So the idea is it's about drawing lines in your system to divide things from one another, so you get clear separation of concerns, and then each component basically has a single responsibility. And when you begin to organize your code according to these principles, then it gets much easier to make changes when the requirements change.
Awesome. And what are some of the things that you have used to help you understand each of those contexts that you have? Have you practiced before the Eventstorming, for example? What experience do you have with that?
Yeah, so I'm glad you mentioned Eventstorming, because that's a really great aspect of domain-driven design that really is a great way to kick things off. So before you write any code, you can create a workshop. We call it an Eventstorming workshop, where you get together your subject matter experts, your domain experts, the people that are really familiar with the business. These are not technical people. These usually are your product owners or your stakeholders, and they really know the business side. They know the use cases that they have in mind. They know the flow of things as they should take place from a user experience experience perspective. You get those people together with the developers and the architects and the UX people, and then you begin to have a conversation as to what the system should be doing. You create what's called a stream of events. For a particular use case, you have one thing happen and then another and then another, and as these things happen, you might see different data on the screen. That the user might take different actions, right? So you define all of that from a business perspective, and you build your whole application on that foundation coming from the business side. And as you go forward, you try to make sure you stay in alignment with those business requirements. And if they change, you go back and look at that Eventstorming session. And usually we do this with some kind of a diagramming tool like Miro, where you might want to put stickies up there to indicate different aspects of this. And there's some really good training on this from Pluralsight that we can recommend. And what you end up with is something that can tell you which services you need to create on your back end, what your front end screens are going to look like roughly, what kind of data is going to be on those screens. You define terms, and you understand the relationship between those events, how one event can trigger another, and who is triggering the event, what kind of user is actually using your application. And that's really what Eventstorming helps you to come up with in the end. So by the time you do it, you're really at a place where when you finish it, you're able to start architecting and building your application.
I see. One of our viewers was asking us before, who should be leading these meetings? What do you think?
It's a really good question. Anybody can facilitate it who's familiar with the process, right? And so I recommend just looking at the Pluralsight training, for example, or there's other videos that are available even for free out there, and understanding what are the steps you want to go through, beginning with defining your stream of events, what commands are involved, what models do you need to represent there, how is it that you have entities that are representing the objects in your business model and how those are related to one another. We have what's called aggregates, and that these are parent entities that contain others. So, for example, an order can contain order items. That would be an example of an aggregate that has children, and there's rules around that. And so you want someone. It doesn't have to be a developer. In fact, it can be usually anybody who's familiar with the process, and oftentimes that might be your solution architect, it might be your product owner, for example. It doesn't have to be a technical person, but just someone familiar enough with the process and the kind of artifacts you're going to want to produce at the end.
Great, Tony, thank you. So that was Eventstorming. Another question that we have from our viewers is, sometimes I get confused with entities, a domain-driven design term, and the DTOs that they're used to. Can you explain the difference between those two? Are they the same, different, anemic entities? What is that? Can you explain to the audience?
Really good point. Yeah, so your entities represent your business objects. So, for example, a customer can be an entity, or, for example, an order can be an entity, or a product can be an entity. And an entity, the main thing about an entity, it has an identity. Right, so one instance of that entity is going to be different from another, and you might distinguish that with some type of an identifier. Typically, you're going to want to make that something like a GUID because it's unique, globally unique, and the other important thing to remember is that entities have behaviors, and that's where your business rules are carried out. So that when you, for example, process an order, you might want to have a credit check. You might want to check if the inventory is available for that order. You might want to bring in the pricing of those products or the taxation. You're going to have those kinds of things. And so entities really are what express your business rules through their behavior. When entities don't have behavior, we call them anemic entities, which is what we call an anti-pattern in DDD. And that's usually what distinguishes entities from DTOs. DTO stands for data transfer object. And what I like to think of it is that DTOs are what your system communicates to the outside world. Right, so if I have a web API, for example, and I want to create a customer, I want to pass that customer into my web API. Well, what I'm passing in is not my entity. I'm passing in my data transfer objects because it's communicating from the outside world into my API. And likewise, if I create a new object or I update an object, I want to pass it back out from my API, my web API, I'm going to also be passing out a data transfer object. And the data transfer object doesn't have any methods on it. It's only got properties, and it just is a way of carrying state from outside your system into your system. And then within your system, there you're going to be dealing with entities. So when you want to persist those to a database, for example, you're going to be working with a repository. That repository is going to take in entities and then persist those entities to the database. But that's internal within your system. It's not communicating with the outside world.
Mm-hmm. Okay.
Exactly.
So you mentioned, sorry to interrupt you. You mentioned repository, and so how do you relate the domain objects with a repository? Can you speak about aggregates and how that helps us with repositories, and how do you usually use that in your own experience, your projects?
Yeah, so a couple of questions in there. One is with aggregates, and the rule behind aggregates is you always deal with the children through the parent. Right, so if you have an order and order items, you don't really directly from outside that order add or remove items. You simply communicate with the order. It manages its own children, right? So that's one of the rules. And aggregates are another great thing because usually when you talk about services or microservices even, we like to scope those at the aggregate root. So as soon as you identify the aggregates in your system, the entities that can contain other entities, then it becomes logical to say, okay, we can create a web service around those entities, right? A microservice, and that's usually the sweet spot when it comes to how you scope your microservices. And then when it comes to persisting those through a repository, that's where you create an interface, and that interface just has usually methods: add, remove, update, delete. All your CRUD methods, they're asynchronous normally because you're dealing with I/O, and so they're usually going to return tasks if you're working in C#, and you represent that with an interface. Right, and so the interface gets injected into your either your controller or your command handler, and then it's that way that thing that needs to save those entities to the database doesn't have to be aware that it's even talking to a database. It's just using the repository interface, and it's calling the methods on that interface to retrieve or update or delete those entities from the underlying data store. Right, that allows you to test your system by mocking out that repository, and it also allows you to change the implementation to a different kind of data store if you need to in the future. So if, for example, let's say you're using Entity Framework, and then tomorrow Microsoft decides, Entity Framework it's in the past, we're going to switch to something totally new for data access. You can make that change, and the thing that uses that repository interface isn't aware at all of the kind of thing that you're actually persisting to.
Awesome. And so we usually are used to the repository pattern, right? When using DDD, that's one of the things that we do. But what do you do when you have to now implement event-driven architecture, right? When you have now you follow other patterns, CQ REST, for example. So how do you modify that initial structure? Any experience on that? For example, when you want to implement EDA and you wonder if you want to continue using repositories, or what do you do in those cases?
Well, I think and this is going to be a shameless plug, but one of the things that you might want to check out is my own framework to help you do this, right? Because it's helpful not to have to reinvent the wheel. And if you have a set of libraries and examples that you can follow, it just makes your life a whole lot easier. And so the thing that I created is called eventdriven.net. And we'll supply the link to that, but it has libraries and examples, reference architectures to show you how to do it. And And so typically, for example, what we like to do is we like to keep our services independent of one another, right? So when you create these web APIs based on an aggregate root, that's your bounded context, right? You want that to be completely independent, and you want to typically have a database per service, right? And you want to avoid, if you can, of course, there's always exceptions to this, but the guidance is to try to avoid, at least initially, any kind of use of a common shared database that among services, because then you have to synchronize the deployments of those services if the database schema changes. So I think so you want to use events to communicate between those services, and this is where event-driven architecture comes in, and patterns like CQRS. So, and I'll show you an example of that when I demo this, but basically you for example could have an order service that needs customer information. Well, instead of making a runtime call from the order service to the customer service to get the information it needs, you can actually create what's called a materialized view of the customer information that you need, but create that in the order service, and we do that using the CQRS pattern. And again, there's in the framework that I have, there's libraries that help you do that, and patterns that are used that really help you get up to speed in doing that. But one thing I'll point out there is that's when we start to talk about events. And we use a different term for the events that are used to communicate between services versus the events that take place internal within a service. So internally within a service, you're going to be using domain events, right? And this is how you can respond to things happening within a service. But when you want to communicate between services, you want to communicate using what we call integration events.
Can you give us an example of a domain event, or reacting to a domain event and reacting to an integration event?
Yeah, exactly. So I might have, for example, an order created event that is within my system, and my entity is going to produce that event, and in response to that event, I might have something in my system that does some logging, for example, or that enriches that order with additional information. Maybe it sets the ID of the event. Maybe it sets the order process date of that entity, and we do that based on the domain event. So that's internal within my system. However, nothing is communicated outside my system at that point. However, if, for example, when I update a customer's address, I want to be able to update the orders, the address of the orders that belong to that customer, and those are two separate services. That's where you publish something over the wire, and what you publish is this integration event. And the reason we have it different is because you want your integration events to have stable contracts, and you want them to be versioned, right? So that if you introduce a change that's a breaking change in the payload, you just create a new version of that event, and that protects the consumer of that integration event from breaking. It'll be able to serialize it based on the new version. So that's why we kind of distinguish. And generally, that's also, remember, you're going outside of your system now. So what you're sending across the wire is not an entity, but a DTO. Right, and so DTOs are sent. Exactly. So anytime you go outside your service, you're communicating, you're passing DTOs over the wire, and that holds true for events as well. Fantastic. I appreciate that, Henry. And yeah, absolutely happy to answer any questions. This is the link to this is the page on the framework we mentioned before, eventdriven.net. And this one, I'm going to bring it up because it kind of has some ways of showing what this thing is all about and how it supports domain-driven design. And then I have a little demo that I'll show you, a little exercise based on this. So if you go to the home directory, this really describes what event-driven.net is all about, and how it's built on what we call a .NET microservices platform, and how there's different layers to that, where they're talking about Kubernetes, you're talking about a message broker that allows you to communicate events between services. There's room for a service mesh in the way of Dapper. There's an event bus abstraction, and then you have your services up here, and plugging in things like analytics and AI as well. And then if you look at an example, which I'm going to show you in the exercise, we're going to get to that. But in terms of the libraries that are available in this framework, they're listed here. And you notice at the very bottom is domain-driven design. So there's a library called event-driven.ddd.abstractions, and all of this is available in NuGet as packages. That's what you build your whole microservices architecture on is DDD. And then layered on top of that, you can do CQRS. You can create an event bus, you can do sagas, events sourcing, and event streams. And you can opt into this model at any layer. So if all you want to do is use DDD and nothing else, you can just start there. And then for the demo, this is what I'd like to show, is this diagram here of two services, right? And here on the left, I have a customer service, and on the right, I have an order service. And they can communicate with each other using events. But before you even get to events, what you want to do is within your service, look at what kind of entities you have. And you see on the left here, we have an aggregate entity called customer. And it's got commands to process. It applies to domain events. And it persists to a repository, right, with a database underneath it. The same goes on the other side. Here's an order entity. It's an aggregate as well. It has the same thing, a repository and a database. We've got at the REST level, we have a command controller and a query controller. So we've got that nice separation between commands and queries. That's our CQRS pattern. And then down here we have the events. And so let's say, for example, we update the customer address. We can publish an event called customer address changed. It's an integration event. And to publish that, we publish to an event bus. And here we're using Dapper, and that sits on top of your message broker. And you see over here, you could use Redis for local development, or you can use SNSQS if you're on the AWS stack, or you can use Azure events service bus as well. And so we have a publication of that event. It goes onto a queue essentially, and then we have a subscription to that event on the order side. It's called Customer Address Changed Event Handler, and it updates that customer address in their orders database.
Awesome. And I can see that on the top that you have, just like you mentioned, this separation between the commands and queries. On this example, I see that you're going to the same database, so you have the separation of those. But in the future, if they wanted to implement another one, how would you apply that one here? How easily would that be using your library?
Yeah, exactly. And so if once you use the library, it's pretty easy. If you then wanted to, for example, have two databases for the customer, you wanted a read database and a write database, that would be another way to do CQRS. And because here we've got CQRS Lite. We are just separating with different controllers and different handlers, but where you get even more independence, scalability is having two different databases within a service. So you could do that, and this shows you could sort of take it to whatever level you want. You can start very simple by having a single database for in the same service, or you can end up having two different services with two different databases for customer. Yep, and again you would use events to communicate between them. Yep. And then I can show you the demo next. And for this one, and we'll provide the link here. This is a DDD exercise that you can do using this library, and it'll help you get familiar with it. And there's some prerequisites here. Docker desktop. You create an instance of Mongo running. So we're using Mongo as the data store, and then we bring in a couple of other tools here as well. And you'll see these are the steps that you would perform. So in this solution, I've got a before solution and an after solution. You can start with the before and run it and start, and you see the dashboard here of the services, customer and order, and you can see the ports they're running on. And then I've got some tests in here. I'm using SpecFlow for behavior-driven design. It's a whole other topic we can talk about. And then some of them are failing, and that's on purpose because we want to update the code in order to make these tests pass.
You're mentioning that you have in your example unit tests, because some of our viewers were asking us before, how do you implement testing or TDD in our domain-driven design approach? So this could be a good example of how you do that. And also we have a video recently uploaded. You can go and check out how to do TDD with DDD. Yes. So I'm glad that you're seeing that in here.
Exactly. And that's exactly what we do. So we have unit test, and we also have what we call integration test or spec flow test. Those two different kinds. And so you'll have to have me back on your show to talk more about that. So I start with
sounds like something's going to happen in the future again. That's great.
Exactly. And here's an example of a repository pattern. So here's an interface called iCustomer Repository. It uses the customer aggregate. That's our entity, and you see there's methods to get, add, update, and remove, and once you have this interface, we go ahead and take that interface and we inject it into our controller, right? So here we have a customer command controller. Here we have a test. So we mentioned unit testing. So we take a test-driven approach here. We create a unit test, and we notice we're mocking out the customer repository. So pretty cool. And then we use a mapper because we're mapping between DTOs and entities. DTOs come in, and then they're converted to entities, and we deal with those internally. And then when they're returned, we convert them back. So I'm gonna
is that auto?
Skip back, please.
What are you using for library for the mappings?
Using AutoMapper. AutoMapper, yeah. So it's been around for a very long time, and it's pretty trustworthy when it comes to doing these mappings, which is really great. And I'm using MOQ for the mocking framework. And so we do all that. We create our test for the query controller, and then we skip all the way down after we've done all of our wonderful testing. And now it's time for us to write some code that actually implements it. So here I'm implementing the customer repository through MongoDB, and then I'm fleshing out these methods here, right? Now, if I can switch over to the IDE, let me go ahead and share that one. I'm going to reshare my screen, and we'll have a look at this one. So this is before. And the before screen, and you can see here's my repositories, right? So the first thing I might want to do is go ahead and add a new interface. Oops, this one. There you go. And I call it iCustomer Repository, right? And I'll just create the interface, and I'll go ahead and add this information here. We don't need that. And now I can basically go back and copy and paste those methods. I can do that so I don't have to spend as much time doing it. Here it is right here. So here I just got my methods like this, and I'll just paste them like this. I'll bring in my namespaces, and you notice it's asking me which type of customer do I want. Notice I have a customer DTO, right DTO, and I have an aggregate. This is my entity, and I'm going to want to choose the entity, right? Because the repository is internal to my service. I'm not sending things outside of it, so I'm going to want to take my entities and then persist them. Exactly. And then you see that, and then for the controller, I'm going to want to, for example, inject an iCustomer repository into my controller constructor. So if I create a constructor, I'm going to create iCustomer repository, right? And I'll just call it repository. I'll go ahead and create a read-only field, and now I can get customers, right? So var customers equals repository dot get async, right? And so there's now that, and then I'm going to want to await that because it's asynchronous, and I just return customers, right? I can turn an OK result with customers. There we go. All right, so that's a good example of where you can create a repository interface
and Tony,
and inject.
I'm noticing how explicit you are with your naming conventions, and that's something very great to point out, because that's one of the things that we want to do in domain-driven design, to be very business-oriented. So anybody reading this has no question about this here. It's not using that much of a generics concept, right? You have no doubt of what this is about. This is a repository on customers. And it's very clear.
Yes. Yes, and exactly. And we're using the terminology from the business. We know what a customer means is defined in our Eventstorming workshop. So it means one thing within the context of this customer service. And so it's pretty cool. And then I've got my domain objects here, and here is my customer entity. Notice that it inherits from a base class called entity, and that's where the library, the event-driven.net library, comes in. Notice that it lives in event-driven.ddd.abstractions.entities, right?
And that reminds me of the concept of DDD, right? That shared kernel. So would that be something that can I relate to that having that common library, right? To where things like entity that you're inheriting over here.
Yeah, exactly. And an entity is an abstract class. You notice it's abstract. So, and if I go into the definition of it, I can do F12 and it'll decompile. Notice that this comes from this package called event-driven.ddd.abstractions, version 2. And notice that it has two properties. It has the ID, because we mentioned entities have identity, and it implements this iEntity interface. And we put in here an E tag for concurrency control, optimistic concurrency control. So that's where this, and this guy is my aggregate root. And so in addition, so I get those properties, ID and E tag, from my base class, and then I can add other things. And notice I have first name, last name, and a shipping address here, like that. And so it's pretty cool. And then I can create events based on this, domain events that get triggered whenever I change the state of my customer, and I can react to those. And then I have also DTOs, and notice I have separate ones for read and write, right? So here's, for example, the DTO coming into my controller. For example, if I go to my controller here, notice that when I create a customer, I'm passing in a customer DTO, right? And that comes from my write customer. So if I can look at that, notice that I have all my properties here, but I don't have any methods. The methods are going to come into my customer when I implement behaviors. I don't have them yet, but in the exercise, you'll go ahead and create those, and you'll go ahead and add those. But we're not going to add any methods to the DTO. And here's the DTO for address. These are write DTOs. I have a read DTO, which is different, which is flat. It combines the customer and the address in one object. I'm separating commands from queries. Exactly. And the query, what the query returns is, it returns a customer DTO. So before I actually, you see, this is actually a mistake here. What I really want to do is also inject an auto mapper, an IMapper, right? And let's go do that. And then what I want to do is var DTOs, because remember, I have DTOs coming in and I have DTOs coming out, right? And what I want to do is map those, right? So I'm going to take my mapper and I'm going to call map. And what I want to return is my customer view DTO. This one, you see how it's in the DTO namespace for the read, because this is a query controller. It's a read DTO. I like to do that. And I want to pass in my customers here. And then what I want to return is not customers, but I want to return DTOs. It says here DTOs are going out because it's a query. And here, this is the command, create, update, and remove. DTOs are coming in. Right? And so I'll do the same. I'll convert these to entities, right? And I'll do that through the constructor as well. So I'm going to add a constructor. I'm going to add an IMapper, and I'm going to also want to add a customer repository, right? So same as I did before. And I can go ahead and add fields for that, for each of these. And I do the same thing, but in reverse. So I'm going to var entities equals, and I'm going to take my mapper and I'm going to map to my entity. So it's going to be my customer, which is here, the first one, in domain customer aggregate, right? So I've got that, and I'm going to convert my customer DTO to an entity, singular, and then I'm going to want to call the create method on my repository. So our created equals repository dot create async, which is add async, and here notice it takes a customer entity. It's going to accept entities, but the only entity that it accepts is the aggregate, because it's a customer repository. And then here I can return my my created entity, like so. So I've got to do the opposite. So exactly. So now I want to pass back a right customer, and then I want to pass in the created entity. And the reason I do this is because when I have a created entity, here we go, it's going to it's going to be when I add it to the database, it's going to get a new identity, or it's actually going to get a new rather e tag, right? And so there's some certain values that are generated by my repository that I'm going to want to return so that the caller of this method has the latest version. So this, I was calling create when I needed to call created, and secondly, this created method requires more than one parameter. So DTO is one, but I needed to actually put in a different parameter, which is the route to the ID here. So that's why I had that. So basically I can just get rid of that, and this is really the correct code right there. Okay, good. So that is really the demo that I wanted to give here, without getting too much into the weeds. What they can do is go back here. There's additional steps in here for beyond the unit tests. If I go down further, it's right here where I actually get to flesh this out. And this is what I was just showing in the demo, that we create an implementation of this. Actually, I didn't show this part in the demo, but what you need to do is, once you create the iCustomer repository interface, you need to create a class that implements iCustomer repository. And this is how I do that in MongoDB. You hook this up in your startup class. So, let me go back to my demo. This is where you hook up your database, right? So if I want to, use an implementation. So for example, here's my interface, customer repository, and go to that one. And this is, just the interface. But if I go back here to the implementation, this is what's using MongoDB. And notice that it accepts an iMongo collection. And then it uses the collection to interact with MongoDB, right? And it's got some base methods that do that as well. So I've got that injected here. And now, how do I wire that up? You do that right in the startup of your web API. First of all, by connecting iCustomer repository to repository, and then setting the MongoDB settings. And there's a nice helper method that I've got in my library called add MongoDB settings, which takes some database settings class, takes your entity, and it takes configuration. And if you go to your app settings.json, this is where you see the configuration for MongoDB. Yeah, you could change this to something else entirely if you wanted to. Yeah, exactly. So in this case, it's to MongoDB, but you could change this to SQL Server or Postgres or any other database that you want to, just by changing this information and then changing the implementation of iCustomer repository. So here you see Docker Desktop, and you'll see that I've got an instance of Mongo. I'll just go ahead and run it. So now MongoDB is running, and then if I go to a Mongo client, I can connect to MongoDB, and we can have a look at that. So this is my Mongo client coming up here. And here it is. So, and you can see right now there's no extra databases in here currently because I haven't created any yet, but those will get created automatically when I write to those through my application. And then this is the solution here, and I'll show you the fleshed out solution. You'll see I've got my customer command controller that accepts the customer repository and the auto mapper. And just as we showed you in the demo, you'll see the create method maps the DTO to an entity, saves it to the repository through the add async method. And then what comes back from that method is then mapped back to a DTO and returned to the caller. And so I can go ahead and I can set a breakpoint there, for example. I can do update and I can do remove. And then in my query controller, it's the same thing, but in reverse. I'm actually passing in nothing or passing in just an ID, and I'm actually returning my DTOs, my customer view DTO. So again, I can also set a breakpoint there and here. All right. And then what I can do is run this and run this service here, and we can go ahead and do it here, right? And this is my startup, and you can see my settings is here. So it looks like we're pretty much good to go. I'm going to start back over here. Here we go. So now you should see the Swagger page for customer service. And if I want to, I can go ahead and create a customer like so. And I can do that. Let me see if I have in my. It just so happens that I happen to have some customers here in JSON. So I'm going to go ahead and just copy that. And first customer is Elon Musk, just by chance. So I'm going to try this out, and I'm going to paste here. So notice that the E tag is blank, but I'm specifying a GUID for the ID. And I've got his first name, last name, shipping address, etc. I'll go ahead and click execute. I'm going to break on the create action in my customer command controller. And this is going to now take my DTO, as you can see is right here. All the data is there. It's going to map that to an entity. So I just go ahead and go over that. And by the way, AutoMapper uses an AutoMapper profile. And this is where I do the mapping between my entities and my DTOs. So I map the customer, I map the address, and then I also map those are the right DTOs, and I also map the read DTOs as well. Right? So that's what my thing is going to look like there. And now I'm going to go into my repository, and this is my add async method. So I'm going to go ahead and locate, run a query to see if that customer already exists. It turns out they don't exist. So I'm going to create it. And so I'm going to go ahead and create an E tag, set it to a new GUID string. And then I'm going to go ahead and call insert1 into the database. And now we have our customer has been inserted and returned, right? It's got everything that it needs. Here's the shipping address, everything. That's my customer entity, but I can't return entities from my method, or I shouldn't. I need to return a DTO. Just like I accepted a DTO coming in, I need to return a DTO going out. So I'm going to do the mapping, and now I'm going to return that out DTO here. Pretty much looks the same, as well as the route to that newly created customer. So I'll go ahead and hit F5. We go back to here, and we see that the result is here. I've got a 201 response code. I've got a location header, and I've got the body right here. Right? So pretty cool. And then I can check if that actually does exist by going back to Mongo. Yep, I'll go ahead and refresh this guy, refresh all. And lo and behold, there's my customers DB. There's my customers collection. And if I go ahead and open it here, I've got the customer with that ID. There's Elon Musk, and there's the address here.
Tony, estamos llegando al final, pero ¿cuál sería la mejor forma que podemos contactarte en caso que tengamos alguna pregunta?
So one of the best ways is X, which used to be called Twitter. So you can do this, and I think let's see if you can find me here. Here I am, Tony Sneed, and you'll see this is my Twitter feed, so it's at Tony Sneed. You can just tweet me, follow me, and we can even exchange private messages with one another, direct messages, or we can just communicate via Twitter. So that's one way to do it. That's probably a really good way to get in touch with me. I do also have a blog if you want to find me, and I like to just Google myself. Here's my blog on eventdriven.net, and you'll see this is my blog right here. So, and you can always comment on this and send me a comment in any of my blog posts as well. So those are truly really good ways to get a hold of me. And of course, you can also go to my eventdriven.net home here, and you can, if you have any questions or things of that sort, you can also post an issue. So if you go to issues here, feel free to post an issue, and you can, for example, if you have a question, you can go ahead and just post your question on GitHub. So those are 3 ways you can reach me.
Bueno, y así hemos llegado al final por el día de hoy. Ya saben cómo contactar a Tony directamente, cómo bajar su ejemplo de código, y alguna pregunta que tengan ya saben qué hacer. Tony, muchísimas gracias por tu tiempo, por la colaboración, y esperamos no sea la última vez que te tengamos con nosotros. Gracias.
My pleasure. Anytime, Henry. Glad to be here. It's been a lot of fun.